So this is the activity I have provided you in my video recording, no? Lab activity 16, no? So we're done with chapter 5. So we now proceed with chapter 6. So for chapter 6 or module 6, no? So numerical solutions of algebraic and transcendental equations, no? So this time we're going to solve the solution of algebraic and transcendental equations, no? So using numerical methods. So for example, so we know how to solve a quadratic equation, right? So say we have x squared minus 4x plus 3 equals 0. So using algebra, we can able to find the value of x, right? So, but we can also apply numerical methods, no? So in solving for the value of x, so I will show later those methods, no, for this chapter, no. So say for a simple example like x plus 2 equals 3, no, using algebra we just transpose, then we get 1, for example, no. So in this example I have x minus 3, x minus 1, factoring it out, right? So x squared minus 4x plus 3. Then I have now the following values of x, 1 and 3, that satisfies this equation. So in this example, if x is 1, that is 1 squared minus 4 times 1 plus 3, we get, shall we get 0? So we have 1 minus 4 plus 3. Okay, so 1 minus 4 is negative 3 plus 3 is 0, and that gives us 0 over equals 0. On the other hand, if x is 3, okay, so this will give us 9 minus 12 plus 3, and negative 3 plus 3, yes, they are equal. Okay, so we now call 1 and 3 as roots of the equation, So in this case, this is an algebraic equation, x squared minus 4x plus 3 equals 0. Okay, so there are cases that it's hard for us to determine the value of x using algebra. For example, if I have this, for instance, x to the 4/3 minus x to the 1/2 plus 2 equals 0. It seems difficult to determine the value of x using algebra. Okay, so I will now introduce numerical solutions in solving algebraic uh, equations as well as transcendental equations. So this is an algebraic equation, okay? But how about transcendental equations? So I'll give you an example of a transcendental equation, okay? For example, if I have sine x equals 2, this is a transcendental equation, okay? Ln x equals 5. So in this case, we are to solve for the value of x that will satisfy the given equation, the given transcendental equation, or a combination. Let's say a combination of a trigonometric function and An exponential function is also a transcendental equation, or a combination of an algebraic and a transcendental equation is still considered transcendental equation. Okay? So algebraic plus transcendental is considered transcendental in general. Now, so this is a transcendental equation, and it will be hard for us to determine x using algebra. So we're gonna use numerical solutions, no, in solving such equation, no. So this is our interest in finding the unknown, no. So we can now proceed. So description, this chapter deals with numerical solutions of algebraic and transcendental equations that has the following subtopics. So we have first the bracketing methods, and under bracketing methods we have the bisection method. So I'm gonna introduce this later. Then another method is the method of false position, or also called as the regula falsi method. And then we have here non-bracketing methods. Okay, so also called open methods. So under this are the following topics: fixed point iteration method, Newton's or Newton-Raphson method, and the secant method. No? So we have 5 topics for this chapter. No? For chapter 6 or module 6, we have the bisection, the method of false position, fixed point iteration, Newton's Newton-Raphson, secant method. So for this day, or should I say for this session, I'm gonna discuss the bisection method. Okay, so let me now continue. So the objectives are as follows after completing this module. So you are expected to apply bracketing methods in the solution of algebraic and transcendental equations, and apply non-bracketing methods in the solution of algebraic and transcendental equations. Alright? So when we talk about bracketing method, this is a method in finding the root of an algebraic or transcendental equation in one unknown, such that the root of such equation is between two given values of the unknown. Okay? In short, I will guess a value, no? Let's say I have the function f of x equals x squared plus 2. Okay? Now, at f of x equals 0, I have the equation 0 equals x squared plus 2 as my simple example. Okay, or ibahin natin kasi wala siyang solution eh. X squared plus 2, x squared equals negative 2. Imaginary number siya. So this is not allowed in this chapter na imaginary number yung sagot. So dapat real number lang ang sagot natin. So ibahin natin minus 2. Okay. So x squared equals 2. So okay, meron na siyang sagot. Positive, negative, square root of 2 is 1.414 something. Okay? So, positive or negative. So, ito yung mga values niya. Ngayon, pag bracketing, huhulaan natin yung value, no? Initial na hula. Let's say, halimbawa, at x equals 1, ano yung sagot ng f of x? 1 squared minus 2, ano yan? Negative 1, tama ba? Yes, negative 1. At x equals, so kung negative 1, let's say at x equals 2, what is f of x? So, dito 1 siya, yung x. Dito, f of 2. So, I have 2 squared. 2 squared minus 2. Tama? F of 2. So, what's the answer? It's this 2. So, as you notice, f of 1, f of 2, the function value here is negative 1. The function value here is 2. So, there is now what we call as transition. Okay? So, there is a change in sign. From negative, it becomes positive. No? Upon changing the value of x. Ibig sabihin, dadaan siya sa x equals 0. Yun ang assumption natin. Kasi mula negative patungong positive. So kung graph yan, ito yung negative 1. Ito yung x equals positive 2. No? Ito yung negative 1. Ito yung x na positive 2. Okay, x and f of x. Okay. So, negative between negative 1 and 2. Nandun yung somewhere in between, nandito yung root. Root is in between. Kasi ang sagot ay disregard muna natin. So, dalawa yung sagot dyan eh. Pero ang kinonsider natin ay yung positive value. Negative 1.4142. Positive 1.4142. So, ito yung ating ngayon, exact na sagot. So, ibig sabihin, yung x na 1.4142, nasa gitna ng negative 1 and 2. So, kaya sinawag siyang bracketing method. So, kumbaga, nakapagitan siya sa dalawang initial values ng x. Okay? Such that, yung dalawang function values dapat opposite signs. So, dapat opposite signs. Okay? So, nandito yung location ng root between negative 1 and 2 that we will determine using bracketing method. And in this session, I'm going to introduce bisection method, which is a type of bracketing method. Okay? So, let me continue. So, we have here non-bracketing method. So, also called open method. No? So, it is a method in finding the root of an algebraic or transcendental equation in one unknown, such that it is based on a formula that require only a starting value of the unknown or two starting values of the unknown that do not necessarily bracket the root. Okay. So, in this case, pag non-bracketing method, open method, so, dalawang case yan. Okay? So, it is based on a formula that require only a single starting value. So, sabihin yan, initially, maghuhula ka ng value ng x. Isang value lang ang ilalagay mo. Kasi non-bracketing isa lang. Ngayon, mula dun sa hula mo, mag-a-arrive ka sa root. Mag-a-arrive ka sa totoong value ng x na magsasatisfy dun sa equation. Okay? So, non-bracketing yan. Okay? Or, dalawang kailangan na values, two starting values, x sub 1 or nx sub 2 or x sub a and x sub b. Dalawang kailangan, pero not necessarily na nakapagitan yung root sa dalawang value ng x. Okay? So, ibig sabihin nun, pwedeng nakapagitan, pwedeng hindi. So, hindi maselan. Okay? So, pwedeng nakapagitan, pwedeng hindi. So, that do not necessarily bracket the root. Okay? So, yun ang pinagkaiba niya sa bracketing method. Alright, so, let's continue. So here's our topic now called bisection method. So for bisection method, also known as binary chopping, interval halving, or Bolzano's method. So it is a bracket method in which the interval is always divided in half. So steps in applying bisection method. Okay, so proceed na tayo sa problem. So para habang sinusolve yung problem, ma-appreciate natin yung mga steps na yan. Okay? So proceed muna tayo sa problem. So saka ko na i-discuss in detail yung mga steps. So here's the problem. Find the root of the equation ln x minus cosine x equals 0. Correct to 3 decimal places. No? So 3 decimal places. So what is the root of this equation? So ibig sabihin ng pag sinabing root, what value of x will satisfy the given equation? No? So this is a transcendental equation involving a logarithmic function ln x and a trigonometric function cosine x. So this is now a transcendental equation. No? Okay, of course, it's hard for us to determine. Excuse me. It's hard for us to determine x using algebra. No. So we're gonna use numerical methods. No. Solution. So first thing to do is we have to let f of x equals to ln x minus cosine x. This is the first thing to do. Okay? Since we are to apply bisection method, and we know that bisection method, excuse me, is we need two values of x, no? Initial guesses of x. So by trial and error, okay, let's say this is 1 and that is 2. If this is 1, that is a negative number, the value of the function ln 1 minus cosine 1 will arrive with negative 0.5403. It's a negative. Now, x sub b is 2. And our target, so that we can apply bisection method, is to have a value of the function to be positive. So in this case, it is positive 1.1093. Okay? Because in this case, f of x here is 0. Right? And f of x sub a, okay? So it's in between the two, f of x sub a and f of x sub b. So 0 is in between. So this is f of x. Right? So this is f of x. Therefore, there is a value of x that can satisfy the given equation that we call root. Okay? So this is our the two function values that are opposite in sign. No? Now, after that, so let's look at the procedure. No? So that we can appreciate further. We can appreciate the steps. Okay. So what is the procedure here? Choose lower x sub a and upper x sub b. Are still there? Okay. Sige. So, choose lower x sub a and upper x sub b, this is, for the root such that the function changes sign over the interval. So, we already did that. We chose 1 and 2. no? Choose lower x sub a. So, sabihin, dapat lower value ng x, then higher value ng x yung isa. Okay? So, we chose 1 for x sub a and 2 for x sub b. So, guesses, we guess, no? Such that the function changes sign over the interval. So, this is the interval, negative from negative 0.5403 to 1.1093. No? The function changes sign over the interval. Okay? So, from this value of the function, negative, to value of this function, positive, in between, there is 0. Okay? And what is the value of x now? Such that f of x equals to 0. Okay. So, that is our goal. Okay. This can be checked by ensuring that the product f of xa times f of xb is less than 0. If we multiply the two, negative times positive, we get negative, and that is less than 0, right? So therefore, we can now proceed in applying bisection method. Okay? So then let x sub a equal to x sub l sub 0 and x sub b equals to x sub u sub 0. Okay? So we let x sub a equals x sub l sub 0, x sub b equals x sub u sub 0. So lower value of x, higher value of x, lower, upper. So we have now 1 and 2 because this was satisfied. This is less than 0. The product of the two function values is less than 0. Okay? And we have initial value of x. Initial lower value, 1. Initial upper value, 2. Okay? So these initial values will now be used, no? So that we can able to find the first iteration, second iteration, the value of x in the second iteration, the value of x in the third iteration, and so forth. Until we reach the root. Okay? So we now proceed. Okay. So next step. So as you notice, so we start with I equals 0. So we will construct a table. Okay? We have I, we have x sub li. So that starts with 0. X sub l sub 0. Okay? Then the function value of that, lower value of x. Okay? Then x sub u, upper value. Then x sub I. So x sub I here. So there's instruction here. So x sub I can be determined using the formula. So step 2, an estimate of the root x sub I is determined. So this is an estimated value of the root. Okay? An estimated value of the root. So is determined by this formula. Lower value of x at the ith iteration plus upper value of x at the ith iteration all over 2. Okay? So meaning we add then we divide it by 2. No? We add then we divide it by 2. Okay? So with that, the next step is so we have to evaluate the function value at that value of x. Then we're going to get the product of f of x sub li and f of xi. Okay? So, and also x sub l I plus 1, x sub u I plus 1, then x sub I plus 1. So let's look at the procedure. Step 3, make the following evaluations. So we have f of x sub li times f of x sub I less than 0. If that's the case, if it is less than 0, we are to set x sub li equals to x sub li plus 1. And x sub I equals to x sub u I plus 1. Okay? So, okay, let's answer this. So, at I equals 0, this is the estimated value 1. So, this is the value 1 that we had obtained. And then we have 2. Okay? So, we will solve for x sub I. So, that is 1 plus 2 over 2. We get 1.5. 1.5. Okay? Now, we will multiply f of xl sub I and f of x sub I. So, ito, negative 0.5403. Multiply natin ng 0.3347. So, it's negative. O, pag negative, ano daw ang gagawin? Ano daw ang gagawin pag negative? O, kapag less than 0, ibig sabihin negative. Set x sub li equals x sub li plus 1. So, itong x sub l, lower value of x na 1, magiging x sub li plus 1 siya. Okay? So, 1 din yon. Okay? For I equals 0. Okay? Sabihin niyan, kung ang I mo 0, x sub l sub 0, siya rin yung equal din siya sa x sub l sub 1. Kasi 0 plus 1 is 1. So, x sub l sub 0, x sub l plus 1. Okay? So, 1. Na magre-reflect dito. When I is 1, x sub l sub 1, 1 siya. Magre-reflect dito sa second row. Ito yung second row. So, kung 1 ito, 1 din ito. Okay? So, madali ito using Excel pagka naintindihan nyo yung process. No? And then, we have the function. Kunin natin f of x sub l. Okay? So, using calculator, makuha natin yan. Negative 0.5403. Okay? Yun yung ln x minus cosine x. Okay? Substitute mo yung value ng x dito, makuha mo yung f of x na yun. Okay? And then, we have, so, upper value, 1.5, then get the average again. 1 plus 1.5 over 2, 1.25. Okay? So, paano naging 1.5 ito? Kasi, yung instruction natin is what? X sub I equals X sub U plus I plus 1. So, yung X sub I dito na 1.5, siya yung X sub U I plus 1. 1.5. Ito. 1.5, 1.5. Okay? So, therefore, siya yung magagamit para dun sa I equals 1. 1.5 na ngayon ito. 1.5. Kaya, ang gagawin ulit niyan, 1 plus 1.5 over 2. Okay? So, 1.25. Okay? So, tapos, pag multiply natin yung dalawang function value, positive ang lumabas. O, anong gagawin pag positive ang lumabas? O, tignan natin yung instruction ulit. Positive yung lumabas. If f of x sub l sub I times f of x sub I is greater than 0, so meaning positive, set x sub I equals x sub l I plus 1. So, Yung x sub I, so yung 1.25 dahil positive, magiging lower value siya ngayon. So mapapalitan na yung 1, magiging 1.25. Hindi na siya 1. Okay? Kasi positive to eh. Mapapalitan na yung 1 ng 1.25. Okay? So mapapalitan na siya. Kaya 1.25 na to. Kaya 1.25 na to. Okay? So x sub I equals to x sub Li plus 1. And then x sub u sub I, okay, equals to x sub u for I plus 1 iteration, no? I plus 1 iteration. Okay. So that is 1.5. Okay? So, ibig sabihin niyan, yung upper value dito, 1.5, 1.5 dito. Okay? So, through practice, makakabisado nyo yung pattern. No? Okay? So, by the way, paano nakuha to? X sub I plus 1. So, add lang, divide to din. Add mo lang yung so x sub I plus 1, so 1.25. X sub Li plus 1 plus x sub Ui plus 1 over 2. Ayun, 1.25. Gaya nito, x sub U sub I plus x sub L sub I over 2, 1.5. So, ganun lang siya. Okay? So, then, ang mangyayari, kapag ka na-reach yung 0 na value, let's say, halimbawa, ano mapapansin nyo dito? Yung product, nag-approach ng 0, di ba? O nag-approach ng 0 habang dumadami yung iteration. Di ba? Nag-approach ng 0. O pagka ganon, the root equals x sub I, terminate the computation. Stop ka na nun. So, therefore, x is approximately equal to 1.303. Okay? And then, so para sa step 4 yun, no? Yung x sub I plus 1. Ito. Add divided by 2. So, step 5, if x sub I equals to x sub I plus 1 to the desired significant figures or decimal places, terminate the computation, else return to step 3. Okay? So, if x sub I equals to x sub I plus 1. So, ibig sabihin niyan, i-compare natin to, yung x sub I na yan, sa x sub I plus 1. So, check natin. At I equals 0, 1.5, 1.25. At I equals 1, 1.25, 1.375. At I equals 2, 1.375, 1.3125. At I equals 10, 1.3032, 1.3030. So, ay ilang decimal places ba yung nire-require ng problem? 3, di ba? 3 decimal places. To the desired significant figures or decimal places. So, ano yung desired decimal places natin? 3. So, stop na tayo. Kasi 1.3032, pag ni-round off ko, 1.303. Ito, 1.303, pag ni-round off ko rin. Sa I equals 9, hindi pa. 1.3037 is 1.304. Okay? So, dito naman, 1.3032 is 1.303. Konti na lang adjustment nun. Kaya, pupunta ka pa ng I equals 10 para maging equal sila. No? Sa 3 decimal places. So, then, therefore, finalize mo yung sagot. Okay? X is 1.303. Okay? Terminate then the computation kasi na-reach na yung desired, no? Desired decimal places. Else, return to step 3. Kung hindi na-satisfy, return to step 3. Ibig sabihin niyan, dadaan ka muna ng 0, then 1, then 2. Kaya nadadagdagan yung I. Yung value, yung I value. I equals 1, I equals 2, I equals 3. Kasi hindi nag-i-equal yung dalawa. Yung x sub I and x sub I plus 1. Okay? So, sabihin niyan, return to step 3. Such that, yung x sub I plus 1, magiging x sub I. Kaya, kung mapapansin nyo, yung 1.25 dito, naging 1.25 sa next iteration. Tapos, na-compute dito, 1.375. Okay? 1.375 sa next iteration. No? Okay, ganun siya. Okay? Yung XLI plus 1, XLI siya nun. X sub U I plus 1, X sub U I siya nun. Okay? So, yun ang procedure. Okay? Ganun siya, ganun yung kanyang pattern. Okay? So we can proceed. Okay, so following the steps, no? So ganito lang ang gagawin nyo. So we will start with I equals 0. And then, makukuha natin tong 1. Okay? So, nananggaling dito. Okay? Nanggaling dito. I equals 0, I equals 0. 1, 2. Okay? So, 0. And then, 1. So, 1 yon. Tapos, ito ay 2. X sub U sub 0. So, kunin mo muna yung function value. Paano mo malalaman yan? Ito. ln 1 minus cosine 1. Okay? ln 1 minus cosine 1. Pero take note. Take note dapat naka-mode region ka. Kasi cosine 1, pag sinabing cosine 1, 1 radian, hindi 1 degree yon. Kasi 1 yan eh. Pag sinabing 1 radian, hindi 1 degree. So, dapat i-mode region natin. Ayan, mode region. Okay, ln 1 minus cosine 1. So, at x sub a equals 1, no? Cosine 1, okay. That is negative 0.5403. Okay? So, ganyan dapat. Naka-mode region ka. So, then ln 2 minus cosine 2. So, 1.1093. Okay? So, therefore, we will accept. Okay? Kasi may change in sign over this interval from f of x sub a to f of x sub b. Negative 0.5403 to 1.1093. So, nagkaroon ng change in sign. Therefore, nandun yung root na hinahanap natin. Okay? So, proceed na tayo. Ayan. So, 1. Then, kunin natin. So, yun yung negative 0.5403. Okay. X sub u sub I. So, ano naman yung x sub u sub I natin? That is 2. Diba? That is 2. Okay. Ngayon, kunin mo yung, pag-add mo yung dalawa, divide by 2. Para makuha mo yung x sub I. Naka-indicate naman yan dun sa steps. Tignan nyo na lang ulit. No? Add natin, divide by 2. 1 plus 2 over 2. So, ano siya nun? 1.5. Tapos, f of x sub I, yun yung ln 1.5 minus cosine 1.5 radian. So, mas kukuha nyo dapat sagot ay 0.3347. Check natin, no? ln 1.5 minus cosine 1.5 radian 0.3347. Ayun, no? Okay. And then, you multiply f of x sub L for the at the ith iteration times f of x at the ith iteration. So, itong negative 0.5403 multiplied by 0.3347, you will get negative 0.1808543. Merong rule dyan. Ano yung rule pagka negative? Pagka negative, ang rule daw ay ito. Ito, negative yan. Less than 0, negative. Pagka negative, yung lower value ng x ay magiging lower value dun sa susunod na iteration. Kaya meron siyang I plus 1. Okay? Tapos yung x sub I, okay, ay magiging upper value siya nun, no? Sa susunod na iteration. Okay? So, sabihin, yung x sub u, yung x sub ui, napalitan ng x sub I. Na equal ngayon sa x sub u I plus 1. Ito yung sa previous iteration. Ito yung sa ito yung preceding, ito yung successive. No? Preceding iteration, x value, successive iteration, x value, lower value, no? Okay. So, in this case, lower equals lower pagka negative. Negative ito, so, yung x sub li dito, magiging x sub li plus 1 siya nun. Okay, dahil negative yan, so sabihin niyan, yung x sub I ngayon natin ay equal siya sa x sub u I plus 1. Okay? So, balik na tayo. Ayan. So, dahil negative yan, yung x sub li plus 1 ay equal siya sa x sub li. Kaya 1 siya. Ito. Kaya 1 siya. Gets nyo, class? Okay.
Yes, po, sir.
Tapos, yung x sub u I plus 1 equal siya sa x sub I. Okay? Kasi negative eh. Kasi negative. Equal ngayon siya sa x sub I. Napalitan na ngayon ito. Yung 2. Napalitan na ngayon ito. Napalitan ng x sub I. Yung x sub u I plus 1 ang pinalit. So, magiging, yung 2 ngayon, naging 1.5 dahil negative. Yun ang kahalagahan niyan, no? So, yun ang use niyan. So, 1.5 siya ngayon. Okay? So, dahil negative yan, ulit ko, yung 1 dito, na x sub li, ay equal dito, x sub li plus 1. Kaya 1 din. Dahil negative ito, yung upper x value ay equal siya sa x sub I na 1.5. Okay? Na yung x sub I na yan ay yung average ng dalawa. xli plus xui over 2. So, tapos, kukunin natin yung x sub I plus 1 by getting the sum x sub L I plus 1 plus x sub u I plus 1 all over 2. So, 1.25. Okay? And then, for I equals to 1, okay? So, for I equals to 1, yung para sa I equals 0, okay, Kokopyahin lang natin, 1. Kasi, x sub L, 0 plus 1, x sub L sub 1. And then, kunin natin yung function value, okay? And then, yung upper value, kokopyahin lang natin ito. Okay? 1.5. And then, yung x sub I, we'll get the average. No? Average ng x sub L sub I, x sub U sub I. 1 plus 1.5 all over 2, 1.25. Okay? 1.25. Okay. So, by the way, meron akong i-add. So, nasabi ko noong umpisa na yung root sa pagitan ng 1 at 2. Kasi XLI, XUI. Sabihin, yung X na hinahanap natin sa pagitan ng dalawa. At ito yung estimated value ng root na hinahanap natin na 1.5. Hindi pa yan yung talagang root. Okay? So, ngayon, nung in-apply natin ito, pag pinultiply natin yung dalawa at negative, yung interval ay umiksi. Umiksi yung interval. Hindi na siya from 1 to 2. Ang root na hinahanap natin, initially, sa pagitan ng 1 and 2. Ngayon, nung in-apply na natin ang bisection method, sa pagitan na lang siya ngayon ng 1 at 1.5. So, nandun na yung root na hinahanap natin. Okay, so kung i-continue natin yan, lumiliit yung interval. Lilit ng lilit yung interval hanggang makarating tayo dun sa ating goal. Makuha yung root. Okay. So, 1.25. Ano yung function value? So, ln 1.25 minus cosine 1.25, negative 0.0922. And then, we will multiply the two function values. F of x sub Li and f of x sub I. Makukuha natin ay positive. Ano yung rule pag positive? O, balik muna tayo. Ano yung rule pag positive? Pag positive, greater than 0, x sub I is equals to x sub L I plus 1. Okay? Baligtad. Baligtad naman kasi positive eh. Tapos yung x sub U sub I equals to x sub U I plus 1. Okay, positive siya. Okay. In short, ganito lang yan. Okay, positive. O kung positive, yung XL I plus 1 ay equal siya sa XL I. Kasi positive. Or should I say, sorry, positive. Equal siya sa X sub I. Okay, kasi positive eh. So, bigyan ko kayo ng para di kayo malito. Ng hint. O, negative, di ba? Pag negative, lower. Ibig sabihin niyan, yung lower na to, equal din siya sa lower na yon. Negative. So, therefore, kaya 1 equals 1. Tapos, yung natira dito, x sub u I plus 1, 1.5, equal siya sa x sub I na 1.5. O, ito naman, positive. O, pag positive yan, sabihin niyan, upper, positive. So, sabihin niyan, yung upper value na to, equal siya sa upper value na nauna, yung preceding. Ito yung successive, yung preceding. Okay? So, Equal yung dalawa kasi is positive. Kasi upper, di ba? Pag upper, mas mataas yung value, di ba? So, sabihin niyan, ito ay 1.5. Tapos ano yung natira? Ano yung XLI plus 1? Equal nun siya sa dito, 1.25. Gets nyo? O, 1.25. Okay? Tapos, 1.5. Gets nyo? Okay. And then, pag add natin yung dalawa, over 2. Pag pinag-add natin over 2, 1.375. So, ang ibig sabihin nito, ang real root, ang root na hinahanap natin, sa pagitan ng 1.25 hanggang 1.5. Lumiit lalo. Una, between 1 and 2. Tapos, naging between 1 and 1.5. Ngayon, between 1.25 and 1.5. Nandun yung root na hinahanap natin. Okay. So, ganyan ang bisection method. Inati-hati-hati natin hanggang makarating tayo sa sagot. So, ganun yung pattern. So, pag ginawa natin yan, mag-a-arrive tayo dito sa sagot na sa mga sagot na to. Okay? So, i-compare nun natin yung x sub I sa x sub I plus 1. Hihinto lang tayo kapag equal na yung dalawa sa desired significant figures or decimal places. So, dito, 1.5, 1.25, wag ka munang hihinto. Next iteration. Next iteration. Next iteration hanggang umabot ka dito. Hinto ka na kasi equal na yung dalawa sa 3 decimal places. 1.303, 1.303. Yung para sa 9, 1.304 pa yan. Ito 1.303. Huwag ka munang hihinto. Okay. So, yun ang sagot ngayon. 1.303. So, yun ang sagot. 1.303. Check nga natin using calculator. ln 1.303. Dapat 0 ang sagot. Minus cosine 1.303. So, 0 yan. Okay? 6.23 times 10 to the negative 5. Kung dadamihin pa natin ng decimal places yan, mas magiging accurate yung sagot natin. Mas accurate yung sagot natin, no? Okay. Okay? I hope you get it, no? So, here's the activity that you will do. Simulate the solution of the given problem using Excel such that when the two given initial values of x are altered, we'll still arrive at the correct root of x equals 1.303 upon extending the number of iterations beyond I equals to 10, applying bisection method. So, ganito lang. Ito, mula Excel lang yan. Kinuha ko lang yan mula Excel, yung mga values na yan. Okay? Nag-Excel lang ako dyan, kaya ganyan yan. No? So, ganyan mismo yung gagawin nyo. No? So, ito yung problem, no? Tapos ito yung iba lang yung subscript, pero pareho pa rin. Iba lang yung subscript na nilagay ko, F minus F plus. Pero X sub U, X sub L. X sub U, X sub L yan. Okay, iba lang yung subscript. O, tapos yun ang sagot. No? Nag-gets nyo ba yung gusto kong pagawa? Okay. So, nakaano na yan. So, So, gumamit ako ng if condition. Ayan. So, nasa diskarte nyo paano nyo gagawin. No? Okay. O paano ba lalagay yung ln? Ayan, ln. Cos. Merong ln tsaka cos dyan sa Excel. Ayan. Okay. O, merong if condition dyan para mag-arrive kayo dun sa sagot. Sa hulihan. Yan. Okay? So, I hope you get it. Sige. Okay.